Okay, in this video I'm going to continue on with exercise 1D on page 28 of the book Fundamental Applied Mathematics, and I'm going to start with question 2. Now I'm not going to read it out, so you can read that if you want, but either way we'll just get straight into it. So the first thing we're going to do is copy the diagram given to us in the question. So we have our x-axis, our y-axis making our xy plane, also known as our Cartesian plane. I'm going to define my unit vectors, I hat and j hat, like that. Now remember again, like that's what actually I hat and j hat look with the little hat on top. Anyway, so we're given that the vector u is in this direction like that, v is in the direction of like that, and we're given that this is angle alpha and this is angle beta. And we're also given that alpha is equal to inverse tan of 3/4 and beta is equal to the inverse tan of 5/12. Alright? Now, remember, we want to be able to get the magnitude of our vector here. So, how do we go about doing this? The first thing we know is that from SOHCAHTOA, what do we know? Well, we know that tan is opposite over adjacent, so we'll say that tan, we'll say opposite over adjacent is equal to alpha. That means that 3 is equal to the opposite of the angle alpha, 4 is equal to the adjacent, and for beta the opposite is equal to 5 and the adjacent is equal to 12. So that's the lengths, the sides opposite the angles and adjacent the angles. So look, here is alpha, here is beta. So what we'll do is, first of all, we will basically decompose this resultant vector. Remember, back at the very start you were given vector A like that, vector B like this, and you might be asked, get A plus B, and what did you do? You put the tail of B and the head of A and draw your resultant vector like this, and this will be A plus B. Like that. Okay, now in this case we're actually given A plus B in the form of u and v, and what we got to find is the vector A and the vector B in the direction of the unit vectors. So we got to find its component unit vectors. So how do we do that? Well, we've done before. We can drop our perpendiculars like this, which is the same as finding its component unit vectors. So we have alpha, we have this, we'll call this vector A, this vector B, and therefore this vector u is equal to A plus B. Anyway, there's the angle alpha. We know its opposite length is 3, its adjacent length is 4, and in terms of beta we can do the same thing. This time we'll go this way. We'll make, because you can pick up a vector and move it around, we know that that vector there is the we'll say is the same as this vector here. Alright, actually it's probably easier to draw it that way altogether. So anyway, this vector here is the adjacent to the angle B, so that is 12, and this one here is the opposite, that's 5. Now, what's next? Well, what's next is to make sure that we have that we've done this correctly. And how do we do that? Well, in the book, or in the question, we're given that the magnitude of u is equal to 10, and the magnitude, remember those straight brackets means magnitude, is equal to 13. So how do we get the magnitude? Well, magnitude, it's a triangle, so we want to get the length of the hypotenuse, which is, of course, Pythagoras, so say h squared is equal to the opposite squared plus the adjacent squared. Okay? Now, here I see what I think is an error in the book, but if your teacher if maybe I just haven't spotted something, I don't know, your teacher may be able to help you out here. But look, in the question you're given that the inverse tan is 3/4 like this, right? So let's just get the magnitude of the hypotenuse. So h squared is equal to 3 squared plus 4 squared is equal to what's that, 25. Okay, therefore h is equal to square root 25. That's 25, should I say, is equal to 5. So that means this is 5, and it's actually given as 10 in the book. So look, you can continue on. Maybe this video is now no good to you, I don't know. But I'm going to continue on as if what I've done is correct. If you've spotted, please, of course, put a comment in the video. Similarly, actually, because of what happens in angle B, I still think I'm correct. If you do the same for B, we'll say that the hypotenuse is equal to the square root of 12 squared plus 5 squared, okay, is equal to square root of 169 is equal to 13, which is exactly as is given in the book. So anyway, like I said, I'm going to continue on as if I've not made a mistake. Please point it out if I have. So what we need to do is add the vectors u plus the vectors u and v. I'm going to say that's a new vector. I'm going to call it a. Now you got to remember that you can only add vectors really the best way to do them is if they're facing the same direction. If they're facing, for example, in the same unit vector directions in terms of I hat and j hat. So if they're in those dimensions. Now if we look at what we have at the moment, you can see that there. But what do we have? We have what is in the dimension of the x dimension. This one here, well, this vector here with magnitude 12, and so is this vector here with magnitude 4. The vector of magnitude 5 is in the j hat direction, and so is the vector of magnitude 3. Next thing is to work out the signs and their magnitudes. We know that in this quadrant here, remember, plus is upwards for the j hat, plus is to the right, excuse me, for the I hat direction. So everything in this quadrant is plus plus. The I hat and the j hat are plus. In the top left one, the j hat is plus and the I hat is negative. Both are negative down here, and the j hat is negative and the I hat is positive down here. And look what we have. We're in these two quadrants here, whereby that one is there and this one is up here. All right. So that affects our vectors. So let's fully decompose our vectors into their unit vectors. So the vector u is equal to minus 4 units in the I hat direction, minus 3 units in the j hat direction. Similarly, the vector v is equal to 12 units in the I hat direction, minus 5 units in the j hat direction. Like that. So if you look at this, these are in the same direction, so are these. Dimension, not necessarily facing the same direction. So we can add them. So if you want to get the vector a is equal to u plus v, we do the exact same thing as normal. We go a is equal to minus 4 plus 12 I hat plus minus 3 minus 5 j hat. Now look, I know what we're doing here is not difficult in terms of adding and subtracting. The difficult part is your algebra. Like for example here, I would always have the plus in the middle, do my brackets, and then do the basic addition in the center. I suggest you do something similar, otherwise you most likely will make mistakes. Perhaps, like I said, up here could be a mistake that I've made and I just haven't seen yet. So anyway, we know that the vector a, which is equal to u plus v, is equal to what? Is equal to 8i hat minus 8j hat. And the book I think says one of those is 6, but it doesn't really matter. The principle stands the same. So I'll rub out all the in between bits. I'll go back up to the start and we'll say that a is equal to u plus v is equal to 8i hat minus 8j hat. Now, what's next? We're given that a vector exists called w, whereby w plus u plus v is equal to 0. Now we're asked to find what w is. Well, we don't know what w is. Let's just say that w is a resultant vector made up of two component unit vectors. I'm going to call them a I hat plus b j hat. Now the thing is, this sign really doesn't matter. If it turns out to be negative, then b will be like minus 5 or something. So it doesn't really matter. You could actually look at it as follows: plus like this. So if b is negative, well then it might just turn into a minus b. So I wouldn't worry about the signs provided you do the brackets like I've done there. So v plus u plus w is equal to 0. Well, we know that u plus v is equal to 8i hat minus 8j hat. So we'll do the exact same thing here. We'll say that w plus u plus v, like that, is equal to 8i hat minus 8j hat plus A I hat plus B j hat. Okay, so that means, and that's equal to 0 because we're given. Another way of looking at that would be that all of this here is equal to 0 I hat plus 0 j hat. What does that mean? It means that all of your we'll say I hat and j hat components sum to 0. So the next step, yeah, you can see that. The next step is to say that 8 I hat plus A I hat is equal to 0 and minus 8 j hat plus B j hat is equal to 0. Therefore, what? A is equal to minus 8 and B is equal to 8. Alright? So therefore W is equal to what? W is equal to minus 8 I hat plus 8 j hat. Now, it also says find the magnitude direction of W correct to one decimal place. So I'm going to do this very quickly now, very quickly, because this is something we've done plenty of times. Okay, so 8 I hat minus 8 I hat plus 8 j hat. I'm going to do this very, very quickly. So what do we do? Look at the quadrant, it's negative I but positive j, so it's up here somewhere, W. So into your component vector, unit vectors like this is minus 8, this is plus 8, therefore H is equal to 64 plus 64 rooted, so that's the square root of 128. So this here is equal to root 128. And what's its direction? Well, its direction is, it could be anything. You could use your inverse sine, inverse cosine, or inverse tan. I'm just going to say that, we'll say this gamma. Gamma is equal to the inverse tan of 8 over minus 8, like that. Don't forget to subscribe. Any questions, comments, or anything like that, please post them on the comment sheet below.